Looked like most of you did a pretty good job on the graphing on the pre-assessment quiz we took, but I did want to just make sure I touched on some different topics in graphing just to make sure everybody's comfortable with them. First of all, if I ask you to find a slope, remember that there are lots of different ways to talk about a slope. We can talk about a slope being a rise over a run, okay? We can talk about a slope, a rise is really moving in the y direction. We can talk about it being a change in y. A run is horizontal. We can talk about that being a change in x, okay? If you think about a change is subtracting two values. So you could take y2 minus y1 over x2 minus x1, and you could use that to find a slope, okay? Lots of different ways to find slopes. Visually, when I'm finding a slope, I usually count the rise and the run. Just be careful. Remember that if you have a slope that goes upward like this, it's going to be positive. You're increasing your y, you're increasing your x. Looks something kind of like that. If you've got a slope that goes like this, downhill in the direction you read, it's going to be negative. Okay, my Algebra 1 teacher always talked about skiing. Okay, where you climbing up a hill, positive slope, you're increasing in height. Are you skiing down a hill, your height's decreasing, negative slope. Okay. Meanwhile, are you on flat ground? Okay, flat ground. You talk about, well, there's not really much of a slope here. Okay, we're just kind of on flat ground. That's a zero slope. Okay, your y changes by 0 as your x changes by some value. And the kind of crazy one there is the vertical line. Okay, remember that vertical lines actually don't have any kind of slope. It's an undefined slope. My Algebra 1 teacher, again, always talked about skiing, and she said, hey, look, if you ski off a vertical slope, what's going to happen? Well, if you ski off a vertical slope, you'd die. You'd splat, you'd hit the ground. So a vertical line goes up infinitely, never goes over. It's an undefined line. And we'll talk about that in a second using the slope definition. But just some basic things there with slopes of lines. Okay? Now, if I want to find a slope with points, instead of counting rise over run, I'm probably going to just use the formula, y2 minus y1, x2 minus x1. You can label any point as your first point, and any point as your second point. So we could call this my second x and my second y, the x2 and y2. We could call this my first x and my first y, x1 and y1. And the formula says, subtract the two y's. I'm going to take 15 minus 5 on top. On the bottom, subtract your two x's. Be careful, it's going to be 3 minus negative 2. And I get a 10 on top. Minus a negative, of course, is the same thing as a plus. And we get a slope of 2. Okay, if you're trying to interpret a slope of 2, it's a rise over a run. You may want to put it back over 1. You may want to leave it as the whole number 2. It just depends on what you're trying to do with it. Okay, but it's going to rise 2 for every 1 that you run. It's going to go up 2 for every 1 that you go over. Okay. That also gives you a little bit of insight into the zero slope and the vertical slope. Okay, if you have a zero slope, you're going to have points like you'll have different x coordinates. And you'll have the same y coordinates. So you'll have points like maybe 3, 4, and then this point over here is going to be 8, 4. Okay, so notice the x's change, the y's stay the same. Well, if you apply the slope formula here, when you subtract your y's, you're going to be subtracting 4 and 4, which gives you 0. You're going to be subtracting 8 and 3. 0 over 5, of course, is really just equal to 0. Okay? Y changes 0 for every change in the x. Meanwhile, if you have a vertical line, the x coordinates are going to be the same. You're basically going to see the reverse happen. You might have a point like, maybe this is 1, 3, and that's the point 1, 7. Okay, and if you apply the slope formula, 7 minus 3 on top, 1 minus 1 on the bottom, you end up with 4 over 0. 4 divided by 0 is really, you kind of think of it as being infinite. 0 goes into 4 as many times as you want it to go into 4. So that's why we say this is undefined. Your calculator actually basically crashes when you find a slope that's undefined. So those are your vertical lines, undefined slopes. Okay? Now, if you're graphing lines, talk about graphing equations a little bit. Most of you probably learned how to graph using y equals mx plus b form. Okay, it's definitely easy to work with. Most people are very comfortable with that sort of thing. Okay, if I give you an equation like y equals 1/2 x plus 5, remember that the m is your slope. Okay, that's a rise over a run. That tells you how your line's changing. The 5 here is a y-intercept, okay? If you're graphing your line, you really need to know a place that it goes, okay? And your y-intercept can give you a place that your graph starts. My graph has to cross the y-axis at 5, okay? Once I know that, I can use my slope. My rise is 1, my run is 2. So I'm going to go up 1, I'm going to go over 2, and plot a point. Okay, and you'll see we get this uphill sloping graph. A perfectly diagonal line, a 45-degree angle, would be a slope of 1. You're going up and over the same amount each time. This one's going to be a little closer to a 0 slope because we're going over more than we're going up. Okay, if it was a negative slope, it would go down. If it was a negative 1/2, you go down 1 over 2, down 1 over 2, that sort of thing. Okay. So that's slope-intercept form. You do need to watch out for vertical and horizontal lines. They're a little bit different. If you think about graphing the equation of a vertical or a horizontal line, think about what's happening here. Let's say that I've got a vertical line passing through 2 on the x-axis. It looks something kind of like that. Think about coordinates of points that would be on that line. Okay? Maybe here I've got the point 2, 1. Maybe here I've got the point 2, 3. And here I've got the point 2, negative 1. And maybe this is the point 2, 5. The point here is, notice, the x-coordinates never change, okay? Meanwhile, the y-coordinates can be anything they want to be. There's no relationship. It's not like the y is always twice the x or something like that. The equation tells you what you know is true, okay? So the equation for this vertical line is going to tell me, hey, x always has to be 2. X equals equations are your vertical lines. Also notice, this doesn't follow slope-intercept form. So we can't talk about having a slope in front of x because it's not solved for y. Those are your special vertical line equations. Okay, horizontal lines, basically the other way. And by the way, notice that that x equals equation passed through an x-coordinate of 2 as well. So that should also make some sense. Okay, if I have a horizontal line, say I have a horizontal line that passes through 3 on the y-axis. Okay, let's look at coordinates of points there. Okay, imagine that that's passing through 3 there. If you look at coordinates of points, all of the y-coordinates are going to be 3. And maybe that's the point 1, 3. And that's the point 4, 3. And that's the point 9, 3. And this is the point negative 2, 3. But we always have y-coordinates of 3. So horizontal lines have the equation y equals whatever the y-intercept is. And by the way, notice something. That does follow slope-intercept form because this is really the same thing as y equals 0x plus 3. Okay, the constant is your y-intercept. It's passing through a y-intercept of 3. Okay, we don't have any x's, so the slope is 0. You get a horizontal line. Okay, likewise, if you had something like y equals 2x, you don't have a y-intercept added on at the end. That's basically the same thing as a plus 0. So whatever's missing in the equation, that part's going to end up being 0. Okay? One final thing I wanted to look at. I wanted to look at intercept form. So not every equation is going to be written in slope-intercept form. Sometimes you might have an equation like 2x plus 3y is equal to 6. Okay? And you have options. You could solve the equation for y. Okay? And you could put it into slope-intercept form. So in this case, I can subtract 2x from both sides. Okay, I'll be left with 3y. I'm going to have an equals. You could write this as 6 minus 2x, but if you think about y equals mx plus b form, we normally write the x first. So I'm going to keep it negative. I'm going to keep the y-intercept positive. Y is being multiplied by 3. I can divide by 3. Everything over here needs to be divided by 3. And so what we end up with is y is equal to negative 2/3 x plus 2. You can see the slope is negative 2/3. You can see the y-intercept is 2. It's nice, okay? It makes it very easy to graph. But sometimes you're going to do this and you're going to get a y-intercept that's a decimal, okay? Or a fraction. It could get ugly, okay? It takes a lot of work. Let me show you something else that can be useful, okay? It's very, very easy with this kind of equation to find x and y-intercepts. And here's why, okay? I'm going to draw some lines that cross the x-axis. There's an x-intercept. There's an x-intercept. There's an x-intercept. There's an x-intercept. What do all these points have in common? I've got no clue what the x-coordinate is, but the y is 0. I don't know what x is, but y is 0. y is 0, y is 0. Anytime you have an x-intercept, the y is going to be 0. Okay? Let me draw a bunch of y-intercepts. Okay, here's a graph. Here's a line crossing y. There's a line crossing y. There's a line crossing y. Okay? Let's look at this. Notice, I don't know what the y-coordinate is there, but the x-coordinate is 0. The x-coordinate is 0. X-coordinate there is 0. For a y-intercept, the x-coordinate is always going to be 0. So you can always set the opposite variable to 0 to find whichever intercept you want to find. All right? So let's take a look at how this can make this really easy to graph. If I want to find the x-intercept, I'm going to set y equal to 0. And what happens is that part of the equation goes away. And I'm left with an equation that says that 2x is equal to 6, which means x is going to be equal to 3. So the x-intercept is at 3. Of course, the y-coordinate there is 0. Gives you an easy point to plot. Okay? If I want to find the y-intercept, well, I just do the reverse. I can set x equal to 0. Okay? If I set x equal to 0, that leaves me with a really easy equation. 3y equals 6. Y has to be 2. Okay? So when x is equal to 0, y is equal to 2. And this gives me two very simple points, very quick points, that I can graph. Okay? So I know that my graph is going to go through the point, through 3 on the x-axis, or the point 3, 0. And on the y-axis, it's going to cross through 2. And it gives me a line that looks like that. Okay? So keep that in mind. It's very easy to graph using x and y-intercepts, especially if these coefficients divide into the constant. So keep that in your list of ideas to try for graphing. Sometimes it'll make things a little bit easier.